talking about preventing phishing and impersonation. We actually renamed it to Backchannel, although I do like Trust Slips. It's a good name too, which is a new relationship-based identity system. This work was done in partnership with Ink and Switch and the New Design Congress. Ink and Switch is an industrial research lab based out of San Francisco. So this week, statistically, probably a few of you got some sort of phishing scam. Usually it's accompanied by some link pretending to be someone very official. And if you click it, you'll probably be presented with some website that looks also very official. $30 billion was lost just in the last year to phone-based scams like this one. They also phish by email using email headers where they can announce themselves as anyone. These are very lucrative attack surfaces. 75% of organizations experience some kind of social engineering attack just in 2020. How do they do it? We need to fix this, right? But first we need to understand how this happens and why it's so prevalent. So with social engineering, there's 4 steps. First, if you're an attacker, these on the right, they're not happy to be social engineered, by the way. These are the attackers. They're very happy to be attacking you. They're mapping user profiles first. They graph the relationship between users and businesses in a social network to try and understand who they should pretend to be. And then once they figure out who they should pretend to be, they disguise themselves as that legitimate actor to fool targets into exchanging data and information with them. Then they extract some personal identifying information and then inflict more serious consequences like exploits or ransomware. This is the newest craze now, as everyone's talking about ransomware all the time, but usually it starts with the social engineering attacks. So organizations, when they try to protect their systems, typically they protect from the bottom up. So they secure their infrastructure. They have really robust key signing and verification processes. They do phishing training and detection, and they have IT teams entirely dedicated to this. But what if we could take a more preventative approach? What if we could stop attacks before they even happen? What if we could prevent mapping and disguising from being effective at all? So this is kind of the angle we're trying to take on this. We've been doing some research on this, and we narrowed it down. I mean, we could also include everything in the world, but we kind of narrowed it down to this idea of user profiles being something that we should tackle as a primary problem. So people have a nickname and a real name, a profile picture. It's put on some public namespace. So in an email, that might be like an email server, or like your local private network probably has some LDAP or whatever. And it's personalized by each user. So each user says, this is me. And this is my profile name, this is my real picture and everything. Here's my description and my bio, my company bio, and all that kind of stuff. So this user profile where I create my own impression of myself is how attackers can then create their own impression of themselves, which happens to look a lot like you. Text messages are usually really good at preventing this, actually, because they'll usually say, a phone number or something. If that doesn't exist in your contact list, if that number doesn't exist, it'll just say the phone number. But Apple is kind of breaking this. So Apple iMessage is actually trying to intelligently detect who the person may be. And they try to say, maybe this might be Alan Murray. All they have to do is say it's Alan Murray. And then all of a sudden you see that as though it's a contact in your list. But this reintroduces the attack vectors present in email that are avoided in standard text messaging apps. And I'm showing you this because I just want to prove that companies like Apple, with all the money and the expertise they have, they're not doing a great job at preventing these attacks. In fact, I think it's because they lack a fundamental understanding in how these attacks happen, or are really prioritizing the user experience and creating really nice design elements rather than trying to understand how these attacks happen and prevent them from happening. So we think it's really important to focus on these questions. So we've identified it as there's some sort of namespace. There's some sort of self-announced user profile where someone can impersonate themselves as someone in that namespace. And it's not independently verifiable. So often these systems, user profile systems, are dependent on some third party, like a third-party server administrator or authority that deems that this user profile is the correct one or valid in some way. So how should we rethink digital identity for safety? So we have some design principles that we've worked on. The first design principle is relationships, not namespaces. So a namespace is used to avoid name collisions between multiple people that share the same name. But instead, we want to build a trusted network of relationships. So this is Notion. It's an upcoming popular wiki, collaborative wiki kind of app. A Notion namespace is defined by the email addresses you add to that team, similar to Google Drive. But they can also personalize their profile and add a photo and all the kind of bad things that we're talking about here. But when we watch how people collaborate, it's actually really funny. Like, despite all of this work that people have put into building these very sophisticated namespace systems and user profile systems, people actually don't use them that much. So you've probably all seen this. This is actually a quite old version of this, but Google Drive offers a share link feature, so users can give access to the document in a video call. So this bypasses the namespace altogether. Like, how many times have you been in the call and someone be like, can you give me the link to that doc? Because where is that thing? So this is a really established mental model. What if we used it as the primary method to share resources and we get rid of the namespace altogether? I think people could actually do that, and it would be a pretty fine user experience. People already do this. So that was the first design principle. Second design principle is recognition. So by recognition, we don't mean like AI or anything. What I mean is, in the human sense, in the user experience sense, the process of understanding that a person you are talking to is actually who you think they are. So user profiles force the recipient of a message to determine if the sender is genuine or an imposter. Phone books are actually pretty good at recognition. Like I said before, contactless and SMS does pretty well. You create a personal, memorable representation of them in your own personal contact list. So I can name someone Becky Trombone because I met them through like a brass band. And someone else can name them Becky 101B because that's their neighbor. Where a user profile, she's always going to be Becky Smith everywhere she goes. So recognition is something we really like about phone contactless and SMS. Resilient. So I think this one's really serious. I mean, I can make it, spend a lot of time on this one, but I'll do quickly. When we trust a third party to maintain our identity, we entrust them with our integrity and privacy of that identity. It's a crime for any post office employee to open mail, but no such law applies to electronic messages. So if an identity provider disappears or decides to cancel their provider relationship or decides to spy on you, you're basically out of luck. So it's not a very resilient system that we have currently. One example of this was Epic Games, where Apple stopped providing identity services to all the users. In the best case, this is inconvenient, right? So you have to migrate all your users to a new system. But the worst case is accounts are unrecoverable. I'm sure there are some people who never got to recover their Epic Games account before it was closed. And so the final one is secure. A collaborative app that wasn't secure, everything might as well just be public, right? So a system that is secure by design means it should not require significant effort to verify security. Users are habituated to warnings. So if you expose users to a lot of warnings, they start to just not even look at them anymore. So this is Signal on the right and Samsung SMS on the left. And they're kind of warning you like, hey, you don't know about this. You want to add them or you want to block them? But like after a while, people start to get tired of these kinds of things. So we want to try and produce something that's secure by design and doesn't have so many warnings. Apple Mail does this by providing a check mark when you verified someone's public key certificate, but it's not turned on by default. This is, we kind of want something that's got the verification of this, but is a little easier to use. So people have thought about this a lot. Like I said, PGP, famously so difficult to use. Most people, even if you've exchanged a PGP or public key with someone, you probably aren't using it currently with them. And it's not turned on by default. And the key servers are similar, where you have to rely on a third party and you have to, hope that they haven't messed with the integrity of any of your public keys. And also, if it goes down, then you can't get access to anyone else's public key. So, social proofs. You've heard of Keybase before. This is it was a pretty big deal at the time. I think they got acquired by Zoom now. They have this idea of where you post your proof to Twitter. This is like your public key. You can post it to other different social media as well, like GitHub and that kind of thing, but it's still a global namespace. So at the end of the day, the burden of proof is still on the recipient. So if I wanted to impersonate Mary Poppins, I could just create an account that's on Twitter that looks like her account. And maybe one of the characters is different, and copy her profile, photo and everything. And Keybase would say, yep, that's Mary Poppins. But you have to still, as the recipient of a message, go and actually check, is that the right Mary Poppins? It's still a user profile that's self-announced with ID numbers. And we're trying to get away from this user profile or any dependency on user profiles. Distributed ledgers, I really don't want to talk about blockchain for more than like 10 seconds, but basically the only thing that blockchain will give you here is it removes the dependency on a single third party. All it does is do this, which is actually pretty interesting, but there's a very high technical expertise required for account recovery, and it's still a global namespace. It's by definition a global, publicly verifiable thing. So people can map and disguise themselves as people. So it's not really removing the mapping or the disguising of part of social engineering. So people can still catfish you or impersonate you. So there's one interesting thing called Magic Wormhole. I don't know how many of you are familiar with it. If I was there, I'd probably be like, how many of you? But it's a command line tool where you can send text or files using a short code. We thought this was a very interesting potential starting place for our new identity system. There's a couple problems with it. It's pretty easy to mess it up or, make sure it works well. So basically how this works, I'm going to go really quickly, but I'll discuss it a little bit more later. You take a code and you give it to someone out of band, so through some other communication channel. And when you're both online at the same time, this insecure Pake server / transit relay transmits and redeems that code. And it can be an insecure channel. We actually don't trust the relay at all, which is kind of a cool concept because anyone can run their relay and you can switch between relays and that kind of thing. So you don't have to, you're not always beholden to the one particular relay that you have to trust. And then so those codes are turned into or derive into 32-byte elliptic curve keys. So these are pretty strong shared secrets, but it's the same secret on each side, right? So there's no ID for one person, ID for another, but it's a shared strong secret that we could use as a pre-shared key to start thinking about our relationship-based identity system. So this is where we kind of started. We're like, maybe there's something here. So we have introduced Backchannel, and I'll show you a little demo what we came up with. So identities in Backchannel are created by redeeming a one-time invitation code. So once this user passes this code to another user, both of their applications generate a strong secret. This shared secret represents the relationships between those two users, and it's used to generate a secure and encrypted connection. Then they assign a name for each other. So instead of naming ourselves, we name each other, and then we can start messaging each other, just like you would in SMS. Yeah. So we experimented with a few different ways to do codes. As you saw before, we were using numbers. That's one we landed on. We also messed around with text, purely text codes, or just using the magic wormhole ones, which are a mix of numbers and codes, word codes. We landed on numbers because we think that numbers are more internationally viable, especially across language barriers. So they're also easier to spell and say over the phone. And it feels more like a single-use phone number. The users that we tested this with were very positively associated with the numbers because they thought, oh, this is like a one-time code or my phone number. Whereas the words were kind of off-putting, right? We have to train people on a few mental models here and try and get them up to speed. So kind of relating it to a phone number made it really easy for people to get started and understand what was going on. It's also easier to understand across languages, like I was saying. You can imagine saying deaf, hazel, lazy, to someone who speaks really good, English might be nice, but then you have to start thinking about internationalizing that to like 30 or 100 languages and it starts to become problematic. It's also unique to each relationship. So these invitation codes, there's no permanent address. There's no equivalent to giving my phone number to someone because my phone number changes every minute or it's a one-time use. So I have to get a different invitation code for each person. So this is a positive thing when we're talking about phishing, right? Because there's no permanent address, there's no spam. There's no way for anyone to just contact me out of the blue if they get my number or guess my number. So what happens when the code is wrong? So it's possible to type in a code incorrectly. That's probably the first thing that happens. So we get one guess per connection attempt. So we're using the same security properties as Magic Wormhole. So an invitation is discarded with the correct guess, and you have to generate a new code. So if there is an active attacker on the network that's just like guessing codes left and right, like for every single number possible, you would probably see many incorrect code errors. This is also why we limit the invitations to 1 minute. You could change that number, but the cool thing about them only being 1 minute long is that it forces people to be online at the same time. So say if I send you the number and I see that it's wrong and I don't get in, but you see that you get in, then there's probably an attacker because I'm like, oh, I didn't get in and then you got in. And so that's kind of weird. So maybe we would just reestablish connection there. Naming. So once you successfully create a contact, you name them. So you're not naming yourself, you're naming the other person. And this name has to be private. So what we do is we save it locally on the machine. It never leaves the machine. It's in our prototype, it's a progressive web app, so it's just stored in IndexedDB. And it should be unique locally. So you have to choose a different name. Should be some verification or validation here to make sure that no other name exists on the device. But anyone could create their own names that are same, but because they're local on the device, we don't really care about a global namespace. It's a local namespace that way. So this satisfies that recognition property of using the same as SMS. We have a contact list that's local. So I can say like Becky Trombone, and that's my contact list, no one else's. So this is a new mental model, right? This is a cryptographic key that is assigned to a person's name. So on the left, you see like Becky could show up in multiple ways in different people's Backchannel contact lists, but if she was on user profiles, she'd be Becky Smith to everybody, or whatever she self-announced. So this is a totally new way of thinking about it. And it's a pet name system. So formally is defined as a pet name system between symmetric keys and local first names. So this is Zuko's triangle, where you have something that's global and unique is a key. So that's the symmetric key. Something that's global and memorable is like a nickname, like google.com. is a global and memorable thing. And then you have unique and memorable, which is a pet name, which is something that's unique to me and also memorable. And so we combine the pet name with the key to create a verifiable pet name system. So like I mentioned there's this relay. So the way that we do this in a privacy preserving way is you connect to the relay using a hash of the key. So you take the symmetric key and do a derived hash of that, and then you announce that hash to the relay. This means that untrusted third parties can provide a relay service, because the only person who's able to connect to that key is someone who also has the original key. Otherwise, they won't be able to read any of your end-to-end encrypted messages. So relays do not learn any information about the contents of the conversation, but they could record IP addresses in theory. So yeah, this PAKE server and transit relay, it's totally insecure. It's something that we think is really important because of the resilience property. So we have a way in the app as well for you to change your relay server. If you give it a URL, you can easily change it to a different server. So talking a little bit more about how it actually works, we separate the codes into two pieces. We have the mailbox and the password. So the mailbox is what is sent to the relay in the initial code exchange. So the password is what needs to be kept secret. So the mailbox is just a way to be like, oh, I'm going to try and connect to these two computers, and if their SPIG2 password exchange is correct, then they'll be able to connect to each other. This means that the password and the mailbox should not be derivative of each other at all. And the mailbox is visible to the relay. So in theory, the relay could guess how many unique mailboxes or how many unique users are currently connecting at any time. Linking multiple devices. So one of the key things that people often ask when they're talking about new systems that are entirely radical is, okay, well, can I do normal things that I would do with other apps, like link my phone and my laptop? And yes, we figured out a way to do that with the system. So I'll just show a little demo. So we borrowed design patterns from Signal and Telegram, where you scan QR code. This is actually doing the exact same thing as the contact adding. So if you notice here, I'm sending a message and I'm seeing that from the same perspective on both sides. I'm sending a message to John. I'm actually going to click in there now. And when I send a message on my phone, hey, this is from my mobile, and I go onto laptop, it actually looks like it's from my perspective. So one of the key problems when you have this multi-device support is what happens when I edit names on my phone and then I edit name on my laptop. I want to see all the contacts on all devices at their updated state. So in order to do this well, we use auto merge, which is a CRDT, a conflict-free replicated data type, to merge changes. So it's just a very simple list data type and the list of contacts. And each contact includes the contacts, and then you have the devices. So the device list is unique on each phone and laptop, and that is not replicated, but the contact list is replicated. So originally I had the devices in the contact list, but I separated them. And if we were in like a classroom, we'd probably do some thought experiment, but we're at Strange Loop, so I'll just give you the answer. But the device list needs to be separated so that we can remove devices and stop synchronizing with them later if they get stolen. So when I synchronize with my laptop and my phone together, they give access to each other's contact list. And they do this through a symmetric key that they derive. And then they save that symmetric key as a device in the device list. So if we lose a device, we create a custom method to revoke the device access by removing that device from the device list. Not only do we remove the device from the device list, we send a tombstone message. So say in this example, the phone is lost. When you unlink the device, a tombstone encrypted message is sent to the phone, and then the phone self-destructs and then sends an acknowledgement back to the laptop. And then once the laptop gets the acknowledgement, it tells the user, okay, we successfully deleted the phone. The phone doesn't have your information anymore. And we're also never going to replicate with them ever again. So we remove them from the device list at that point. So this is a little example demo here. It's working. So over here, this will unlink all devices and delete the data, including contacts and messages. So if you notice on the left, it just wipes it out without telling the user that it did that. So our overall findings, I have a few more minutes and then I'd love to hear live Q&A. This can work for more than just chat. So we prototyped it for chat. We also prototyped some designs for document review. So here's an example of using the same system. This is a Figma design prototype where I'm sharing this document with someone and they input their code, success. I call them Jenny, give her access to the reviews. And then I can start seeing as people comment. So it's the same underlying data types. I'm just rendering it in a different way. Like this is just a message from Bob where Bob has commented on some line. And then I can maybe remove Bob from it. So this is interesting because maybe Bob doesn't, I don't want Bob to see Jenny's edits. So the way people would do this nowadays is they would create their own, they create a different document for every reviewer that they send it to, for example. Here's another one where like location sharing, like the Google location sharing feature, where you have like an invite code and you send that with a QR code. So we experimented with a lot of different ways of rendering these codes. That was actually a lot of the user experience work we did. So we tested this with journalists and researchers and non-techies and designers. And it was really interesting. This was probably the hardest part, was figuring out what is the best way to render these codes in a way that is actionable and makes sense to people on the first try using the app. So we landed on this design. The visual indicator of how long you have left, the QR code is for scanning in person, and the numbers should resemble a phone number. I know we're in the US here, but this is like a phone number from Europe. But it would resemble a phone number. I guess if you were targeting users in the US, you might format it differently. But we also experimented with drawing nicknames. We felt like this was a fun thing that users actually really enjoyed when they were playing with it. It also helps to really confirm that this is really a person that you know that's contacting you, and you can like personalize that contact list a little bit. It's just kind of a fun thing that we were experimenting with, people liked. So we tested this with 12 journalists and researchers once we got to the final design. And very few mentioned that they didn't need an account. They didn't even notice that they didn't need an account or didn't need to create an account or didn't need to verify their phone number or anything. So I thought that was a really interesting fact. And that is actually a good thing when people don't notice something. They just get started right away. That's a great thing. So that was very cool. We also noticed that people needed some new mental models, especially developers as well. We have to start rethinking how identity works. And this is going to require new ways of thinking about how device linking works, how profiles work. You know, I don't have a profile. I create profiles for other people. So there's some learning that is probably going to have to happen here for users and developers. So we have some known vulnerabilities. This is a prototype. So there is an open source software implementation. The relay is a single point of failure. So although the relay is untrusted and you can switch relays, it's still just a dumb echo server, right? So it's an echo server, but it has to be up. Like if the echo server isn't on, then you won't be able to use this. So there's some in the paper, we outlined some alternatives for that. You could put in a CAPTCHA maybe to try and prevent spammers and DDoSers from like trying to bring it down. But there are some risks involved there with having just like a single server to do this. Key revocation is tricky. Like we have this sophisticated unlink process, but you know, there's probably a lot of edge cases and things to think about there. We didn't spend that much time on it, to be honest, like a few months. So, you know, this is just the beginning, right? And then key rotation is not included in this prototype. So ideally, you would take this symmetric key and then start rotating it with every message using something like the Signal protocol. But we didn't implement that because we figured, you know, that's kind of like replacing one library with another. Like we're just using web crypto right now, but it is possible. We did experiment with that. We have an open source prototype for that as well, of combining SPAKE2 with the Signal protocol, and that does work. But yeah, I think production applications will really have to think about these things if they're going to try and implement this. So what's next? So this is a very big deal for local first apps that we build at Ink and Switch. So we're really focused on long-term ownership of data, and we want to be able to have that data ownership forever. But there's a lot of open questions regarding synchronizing and status of messages and who has access to what. So I think that I would like to do more applications that combine this kind of approach of Backchannel and relationship-based identities with local first software. In our prototype, there's no storage peer. So if you're not both online at the same time, there's no like peer in the cloud that's going to like have a copy of all your data. So, I mean, there's a lot of work to do there, but I think this, you know, if a production application wanted to tackle these problems, they could definitely do that pretty easily. It's just time that we didn't put into in the prototype. And then people always ask groups, right? Love to work on groups next. So one of the key problems is, okay, so if I want to create a group with multiple people, do I have to send each of them a code individually? How does that work? So yeah, we could do that. It could be like SMS, where if you get added to a group chat or group document, you don't actually know the names of everybody and you have to ask them. Like that's how SMS works right now. Could be referrals and gossip. So there's some prototypes of this where you can like nickname someone else and I can like share my nicknames to other people in the group. But I think that have to be done with care, so people know that they're sharing their private names. And then you could also just reintroduce user profiles with a preference for local names, but it kind of defeats the whole point. So, but I could see people, if you're in a production app and you really wanted to have this as an option for people, I could see people doing that as well. I think one of the bigger takeaways here is how this might be able to be applied for enterprise. So I don't know if you're familiar with the big Twitter hack, but I think it was last year, Twitter got hacked and all these companies were sitting, like big names like Barack Obama and Trump were like, oh, give me some Bitcoin. And this was, Twitter got hacked. And the way that they dealt with this is every single person in the company needed to get into a video conference with their supervisor and manually change their password in front of them. So the idea of, in an enterprise, getting on a video call and exchanging a one-time code with your supervisor is not that crazy of an idea if people are already doing this kind of thing. So there might be something here about organizational security to think about for future applications. This is the team. I'm Karissa. I led this project along with Ben, Chris, who designed and developed the prototypes, with Kate and Peter, who are amazing advisors. So are there any questions?
Do users ever run their own relay server?
We just released this last week, so I don't know, but they could, yes. There's a part of the app where you can go change your relay to a different relay server if you wanted. And all that code is open source. You can find it on this link.
Did you ever look at SIP, session initiation protocol, as a potential part of this?
Someone sent that to me and we thought it was interesting, and I think it could be like used in conjunction. I haven't, we were trying to find, part of the research goals here, we're trying to find something with the most simple offering for like small teams who want to build applications. So I think, yeah, I mean, I would love to look more into that for future work. But yeah, we were trying to reduce as many dependencies on other things as possible.
Hey, thank you for your talk. I was really curious how you deal with the revocation of the device linking. Do you have it so that like you can only look at your messages while you're online, so that once you go online, like you get deleted? Is that how it works? Or like how do you manage like someone being able to keep the device offline and potentially see messages that already exist versus like that revocation?
Oh yeah, that's a good question. I would say in that train of thought, it works very similar to other apps. So like if you were, so yeah, there is that vulnerability. Because I think like WhatsApp would also probably be the same. If you were totally offline, you would never get the message to unlink. So you could see the messages that were local or already downloaded. It's a hard one. I think, yeah, you could force people to be online, but I think part of the work here is like trying to make something that works forever in case the relay goes down or isn't available or you're not online. Like we want to still have apps that work while you're offline. So yeah, I think that it's still tricky, and maybe it's a per user setting. So I think there could be something interesting there in regards to like what people's risk levels and threat models are, because people have different threat models. Some people have a really high risk of their phone getting stolen, and other people might have a high risk of their laptop getting hacked or something. So there's, yeah, different threat models for different people. I think that maybe some people are always online and they don't mind forcing themselves to be online all the time. So that's a good question.
I have a question. I've heard that in like ye olden times, like there wasn't the concept of a single government name, or like I guess people had different names in different contexts. Were you like inspired by this sort of, or what? Am I just talking nonsense?
Oh no. Yeah, it's a funny one, because when we were first starting this project, I was talking to Peter, and he was like, "Yeah, well, maybe like Joseph of Nazareth, is like joe@nazareth.com. Like maybe that's why email is so popular, is because it follows this conventions of like my name at a location that we've been using, culturally or something." But I think that's an interesting a point. I think it's useful to go back in history and think about people's like cultural representations when you're designing user interfaces like this, because different cultural representations of themselves or other people is going to play into how well they understand the system. So, I mean, I think I wouldn't say that we did much of that. I think we were mostly inspired by just our work on like social engineering over the past few years, and specifically with New Design Congress and the work that they had done on this research. So.
Okay, I think we're at time. Thank you very
Thank you.
much. That was wonderful.
Thank you so much. See you in GitHub.